Before we start the video, a large thank you to Void Playing Games for their support on Patreon. I hope you enjoy the video, my friend. And a massive thank you to Halo Burner and Ryan Bellin for their immense support to the channel this month on Patreon. It is greatly appreciated, gentlemen, and I hope you enjoy the video. Hello guys, hope you're having a very good week. So in the last video, I showed you that if you don't use pivot, you kind of got this. I'll just show you again, check this out. Watch what happens when he shoots at me. He's going to run around, but he does this weird little like circle thing. And I don't notice this in Nev because I always make the character pivot, but if you don't have pivot animations, that can be a bit of a problem. So I'm going to give you a better way to do this so they won't do that little roundabout thing. And I actually discovered this making the Diablo and Unity series. So go to your rotate towards agent function on the AI character combat manager and comment this out. And what we're going to do instead is, because right now this basically takes the rotation of the Navmesh agent and it updates after the Navmesh agent is updated, but we're going to instead get the rotation source by referencing the Navmesh agent's steering direction. So first just do a if you're not moving return, and then we're going to do a vector 3, and then we're going to do a desired destination direction. And we're going to get that by taking our AI character .navmesh agent .steering target, and then we're going to subtract that basically. And this is just basically the current direction the Navmesh agent is trying to steer towards in regards to the point that it's going towards. And then we're going to subtract our AI character transform opposition, and that will get us our steering direction. Now, make sure you set the Y position of that direction to 0. And then from there, we're going to normalize the direction. And now we just need to do some rotation. So we're going to say first, if the desired direction dot square magnitude is less than 0.001f, just simply return. And if it's not, then we're going to actually apply some rotation. So we're going to say quaternion, then we're going to call this our target rotation is equal to quaternion, and we're going to say look rotation, and we're going to pass the direction of our destination we just got. So then we're going to say AI character transform dot rotation is use quaternion dot rotate towards, and we're going to pass our current rotation, and then we're going to pass the target rotation. So we need a speed for this, and my understanding of this call is that the speed is basically, if you multiply by time dot delta time, is going to be max rotations in a second. So 360, for example, will be 360 degrees. So we can say header over here in AI character locomotion manager for rotation and make a public flow for rotation speed. Now let's see if you want to move that rotate towards agent over here. Before we were using it to, I believe, in combat stand state calls. That's why I put it over there, but it does fit on the locomotion manager as well. So then we're going to say AI character locomotion manager rotation speed times time delta time. And now let's jump in and test this to see what an appropriate number would be. So I'm going to save that now, and I am going to, like I said, you could copy this and bring it over in the locomotion manager if you want. So you can see there, that's already a lot better, and I think I have it set to what, 360, so let's pause. Let's go there. Yeah, so we got 360. So let's try 2000. That might look a bit too harsh, but we'll see. It's already oceans better though. 360 is honestly probably fine. Let's just see. So if I get this guy to shoot at me, and then he's gonna, okay, he's strafing right now. I'm gonna get closer, so he actually runs away. Yeah, so that's like instant. Honestly, maybe too harsh. It kind of depends. I'd rather the pivot animation, obviously, but that looks pretty good. So let's try 1000. I think 360 was probably fine, but we'll just try this. Let's see. All right, let's make him run away again. Take a shot. Okay, yeah, that's a lot better. All right, so 1000 is pretty good too. So now, someone wanted me to do walking backwards as a strafing pattern. So I think the trouble there is implementing it with our current patterns where it's not messy. So let's go and make an enum for it. Under pursuit mode, let's make one for strafe mode. And we're going to have 2 starting out. If you want me to cover more, just let me know. We'll have standard, which is the left and right straight. The left and right strafe. Say that 10 times fast. And then we're going to have avoidance, I'll call it, which is they're just going to walk away from you if you meet a certain threshold distance. Think of it like retreating, but you're not sprinting away to a position. You're just like a person while still strafing. So let's go over to our combat stand state, and where we have will circle target, and that's a bool, let's instead make this a strafe mode variable. And instead of will circle target, because it's no longer just circling, I'm going to rename this to strafe mode. And defaultly, I'm going to set it to none. So if you want to defaultly set it to something else, that's cool. But none means basically like they won't strafe. Has chosen circle is going to be has chosen strafe pattern. or actually we'll call it strafe direction. There we go. And the strafe movement will stay the same because we can still utilize that. Now, let's clean this up a bit. So under set circle path, what we can do here is we don't need this if statement to contain all the strafe values. And comment out this check for touching a wall, because I'm going to touch on near the end of the video why we're going to change that, because we're also going to make a check for falling off a ledge. So for now, comment that out, or you can keep it there until the next video if you want. It's up to you. So horizontal movement is equal to strafe movement. That's all the same, but we're going to do a switch statement up here for the strafe mode, right? And then we have none, standard, and avoidance. So we're going to copy these two values, and this is if it's under standard. And then under avoidance, we want to just basically invert this. But we need to make sure it's always a negative value because we always want to walk backwards. So we're going to do that. And we're also going to make this code below a bit neater. So down here, we can copy the switch statement, copy the one where it's right so your values are positive, and delete everything inside both, right? And now we can also just paste this, and we can delete the else on this statement here. I'm going to put it below actually first, so do the values first and then come down here and then delete the else. And again, make sure these values are positive. So what we're going to say here basically is if it's left, then we're going to make the values negative. And we're going to do that by saying strafe move amount times equals -1. Just like that. That's so much neater. Saves a lot of space too. Now, we also need to basically say, or if the strafe mode is set to avoidance, we also want it to be always negative because we're always going to walk backwards. And that should cover our bases. So we're going to say set value to negative if it is left, or we are set to strafe mode avoidance. If you guys test this also and there's a problem, just let me know. I'll address it. But I'm going to test it in the video real quick too. I won't go over every little nook and cranny of weirdness because I'm going to do another video on this for detection on path. So if the strafe mode does not equal strafe mode none, then we're going to set our circle path. That's the error you'll have there because it used to be a bool. Now go to the combat stance and set it to avoidance, and I'm going to set it to walk, and go to your attack state also. And we can comment out this update movement parameter 00 because if movement is false, it's going to go to the idle animation anyway. So you can just remove that there if you want to, or comment it out. And go to the ranger state, and I'm going to make sure I go over now and make sure we're not retreating. And under the combat stance state, I'm going to make a serialized privates float here. I'm going to call this minimum distance needed to avoid strafe. And this is going to be, I'll say avoid strafe backwards. This is going to be how far the character needs to be before you start actually moving back, or how close they are, rather. I think 5 is too low, but we'll test it. And then down here, under our switch statement, I'm going to say if our AI character comment manager dot distance from target, we're going to say is less or equal to the minimum distance needed to start walking backwards. And then we're going to change our vertical movement to 0. Otherwise, we're going to do our strafe movement to the movement amount it's supposed to be. Actually, I don't think I'm supposed to put this here because this is going to cause like a moonwalking juddering thing. Yeah, this is supposed to go below. It's my bad. Hang on. So just copy this if statement here. I'm just going to finish writing the comment. I'll copy it all at once. If the target gets too close, walk backwards. But we're not going to keep it here. So let's rip this from here. And then I'm going to basically just undo what I just did and put this as it was. Vertical movement is equal to strafe amount. But then down here, because every time we leave the combat stance state, we're re-rolling the strafe. So we always come back down here. We're going to say if the AI character distance from target is less than or equal to the minimum distance needed to strafe backwards. Actually, we're going to say if it's greater than. So if the distance of the target is greater than the minimum distance we need to strafe, then we're going to set the strafe amount to 0. And we're going to make sure if the strafe mode is set to avoidance as well. And I just deleted my comment, so I didn't even copy that. I don't know why I wrote it out. Okay, so I'll comment up here. If the target is already far enough and we are set to avoid, then we're going to set the strafe movement to 0 instead so we don't get back further. Otherwise, you're just going to endlessly walk backwards. So if I go into the game here now, you can see they're walking back, and then they're walking forward when they get too far away from me. Okay, so that's cool. But I think 5 is going to be too low of a number because, yeah, okay, they're still walking forward. So I pause the game, go to the combat stance state, and set this to something like 10. I feel like 10 is probably, actually 8 is probably better. We'll try 10. And yeah, they're walking backwards, and after they get so far away, like he should start walking forwards if I let myself get further. So yes, okay, cool. All right, I believe it was James who requested that. There you go, James. You have a way to walk backwards now while still keeping your old strafe logic in the same state. Okay, so before we move on, I have some pictures here I want to show you because I'm going to talk about what we're going to do in the next video in regards to what happens if the character were to back into a wall or a ledge, and we're going to stop them from walking off the ledge or backing into the wall. But also, this is very important because it will affect your combat in so many ways if you have a very large character. So on the screen right now is an image. You can see I have 2 green dots, one on my player and one on the potential target, right? Now you can see that these are basically the transform dot position point. And you'll notice that obviously it's the perfect center of the model most of the time, and the model is going to come out around that. What I'm trying to say is that basically your model is bigger than the transform dot position point, and there is a set amount of distance between the point and the edge of your model's collider. Now this isn't a problem when we are dealing with things that are like humanoids and everything's around the same size. But what happens if I instead have a very large creature? Think like a dragon or a giant or something like on the scale of Elden Ring where you're fighting a boss. Well, this now becomes a problem because the distance between the target is calculated from green point to green point, right? And that's not so bad right now, but think about your attacks then. What if you have an attack that requires a minimum distance of a target to be, say, like, I don't know, 2 meters? And this is a rare situation, but it can happen. But then let's say the point between your green dot and the edge of the collider is like 5 meters. This is just hypothetical. What will then happen is that attack is never possible. So you'll never actually get to perform it. And what if you want some very specific logic where you're looking for the distance to the edge of your opponent's collider to perform some kind of attack and not the edge to their center? So another example is maybe you have a very tiny little dog or a zombie creature against a massive giant, and maybe one of their attacks at ultra close range checks only for a meter, and you do a quick swipe. Well, you're never going to be a meter away because you're measuring from the distance to the center of that giant, and from the center of that giant to the edge of his collider, it could be 2, 3, or 4 meters, if that makes sense. So the solution now is to calculate the distance based on the distance from the edge of the character's controller, collider, not from the distance to the middle of their transformed out position point. And this is obviously going to be a little bit different depending on the direction you're facing in how we're going to write the logic. But this is a fun little challenge for you right now because I'm going to cover this in the next video because it ties into our ledge detection system as well in terms of the logic we're going to use anyway. It's a little bit similar. So I think you should try to write some functionality to determine the distance between the edge of our player's character controller and the edge of the target that they're facing. So the edge obviously closest to the character, the edge that's facing us, not the edge that's away. So if I'm facing you and you're facing me, your edge will be closer to the front of your face, not the back of your head. So try that out. I think it'll be a fun little challenge. And if you're feeling brave after that, go ahead and implement that in your AI character target check. When you're checking for that distance, check for the distance to the edge of the character controller, not to the center point. I know that was a very long-winded explanation, but I felt like it was necessary. I really wanted you to understand what I was saying there through the examples and the images provided, so I hope that helped. If it's still unclear, please let me know. I can describe it further. But if not, that will be all from me. I hope you have a very lovely weekend. Thank you so much to my patrons and the people who take the time to like and share the video via word of mouth, who leave a comment. The series is only possible because of people like yourself, and you have my sincerest gratitude. I will see you guys in the next one.